Thanks. So next up we've got Jit. Jit's been a long-time speaker at the Atelier. We've had him on numerous occasions. Really glad to have him back. He's based in Manchester, works for the BBC, and he's going to give us a talk on speed versus quality. Can you have both? So over to you, Jit.
Thank you. Right, I have a tendency to speak a little bit quiet, so those of you at the back, give us a wave, right? If I go a bit too quiet, wave at me so I know I need to speak up a bit. Can you hear me all right, yeah? Yep. Okay then, so we often believe that in order to go faster, to deliver more value quicker, you have to sacrifice quality. And to deliver high quality products, well, we have to go slower. But why do we think this? So imagine a team that has a reasonably high bar for quality and that can deliver an acceptable level of speed. Now, let's say there's some pressure from somewhere in their organization to see if the team can deliver, a little faster, just for a short time. So the people in the team work a little harder. And at first, they're pretty good. Maybe they work a little longer, they work through their lunch breaks, they stay a little later, they start a little earlier, and they get faster. Now, quality drops, but by an acceptable level. And so no one really notices, and everyone's pretty happy. Now, maybe this fictional team is congratulated for working harder, going the extra mile, pulling out all the stops, moving that little bit quicker. Maybe some team members decide to push a little harder, answer those questions for those requests of features out of hours, maybe offer some advice when they're on holiday. Maybe some more requests coming from the organization to see if the team could, fulfill one more request. Just this one. It'll only take a minute, a minor tweak to the UI or feature. This time, though, they take a teeny tiny little shortcut. Maybe they don't spend as much time thinking about what risks could be introduced when they make this change. Maybe they don't create a ticket and run it through the team's boards like they usually do. Maybe they don't pair on the work with another developer. Maybe they don't chat to their testers on the team about, what they think the problems could be and what risks there could be. Maybe they skip writing the test to get it out of that little bit quicker. Nothing malicious like pushing code directly to production by bypassing the build process. And the team go a little faster. But this time, quality drops too, which a few people notice. Maybe your testers who raise a few more bugs. But it's not clear if it's the fact that you're working hard or the work is actually hard to do. And because of this ambiguity in the situation, some people decide to double down and see if they can go even faster. It's what everyone wants, the business, the users, even the team. Maybe they take even more shortcuts, skip a couple of meetings here and there, sit on your laptops during that meeting, no one will notice. Maybe, don't go on the training courses about leadership or mentoring. Maybe skim working with more junior members of the team, you'll show them next time. Maybe you brush that bug in production under the carpet, you fix it now, no one needs to know about that. And the team goes even faster. But this time, quality has really dropped. So much so that your users are complaining more regularly. Even your head of department's getting direct messages from their users about the problems that they're seeing. Quality has finally dropped to an unacceptable level. And we've now finally sacrificed speed for quality. So, how do we close the quality gap? Well, because of that ambiguity, is the work hard, or is it because or we're working too hard? The obvious answer here tends to be more testing. If we can catch those bugs before they go into production, we can surely keep our speed while also improving our quality. So they add a waiting for test column. Every ticket worked on their team now must go through all the testers. But testers can't test everything, so let's help them out by automating more of their work. Now, this causes quite a few problems. But the main one for this scenario is that it's pushing testing towards the end of the development process. And the problem is that as the quality goes up, the speed starts to drop, as testing starts to become the new bottleneck to the team's delivery process. And if you're interested in learning more about what pushing testing towards the end does, then check out that link there where I go into more details about that. So it's no wonder that we often see quality and speeds at opposite ends of the spectrum, especially if the best way to increase speed is by working harder, but in order to increase quality, you must do more testing. But is there a way we can have both? Hello everyone, and welcome to my talk, Speed versus Quality, Can You Have Both? My name's Jake Gossai and I work for the BBC. And for anyone that hasn't heard of us, we're a public media broadcaster. You'd be surprised, there's always someone who doesn't know who we are. And basically means we create content that goes out on TV, radio and digital services with an aim to inform, educate and entertain the British public. Now, I work on the tech side of the organisation, better known as a product group, which houses all of its main digital services. And I work more specifically on the on-demand side, better known as iPlayer, its video on-demand service, and Sounds, its audio on-demand service, which are available on multiple different platforms such as web, TV, smartphones, and smart speakers. And all of these platforms are supported by dedicated multidisciplinary engineering teams. Now, I work as a principal tester across the department. And what I'm particularly interested in is creating a culture of quality, which is one where we don't just inspect for quality by testing for things at the end of the development process, but one which looks to build quality in at every level that we work, from the products that we build, to the processes that we use to build those products, and into the very interactions of the people who use the processes to build the products. And I call this approach quality engineering. And if you'd like to learn more about that, then check out my newsletter where I talk about this and loads of other things as well. And you can also find me on Twitter or X and LinkedIn as well. Now, one of the ways in which I help engineering teams is by helping them see how they can do things better, faster and cheaper, but most importantly, sustainably for those engineering teams. And one of the conversations that I often get into in and outside my organization is, what does speed and quality mean in software engineering, and can you have both? So, can we? Well, let's look back at our little hypothetical scenario from earlier. This time, instead of the pressure to work harder, the ask is going to be to work smarter. How? By not directly focusing on speed or quality, but our capability to do the work. And specifically, to improve it using experimentation, to encourage trying things out and seeing what does and doesn't work. Now, this is where things can sometimes get a little bit derailed. When you start working on your improvement capabilities, there's a good chance that instability is introduced into your existing process, and your speed, quality, or both, as in this case, can drop. And this is usually where the derailing happens, as people panic. If you're trying to improve your capability and then your speed or quality drops, it can seem counterintuitive. You're trying to get better, not worse. Now, what happens here is that panic leads people to stop the improvement process and go back to the existing process, and suggestions are made, maybe now not the right time, maybe next quarter will be better. What I would say here is, what we need to do is improve our ability to learn from failure. And that rather than only trying to mitigate failure, we should embrace some level of uncertainty and learn from it. But for teams to be able to truly embrace improving their capability through experimentation and learning from failure, they need the support of their leadership team to give them the time and the space and the reassurance that they understand that some instability is inherent with experimentation, and that they as a leadership team believe that their engineering team can figure out the best way forward to incorporate that learning back in their capability to do the work. And with time, they'll begin to see that not only have they improved their capability to do the work, but they've also stabilized their quality to levels like better than before, but also they've improved their speed. And they've done all of this sustainably without resorting to working harder. Now, these two models of working harder and working smarter are taken from a research paper called "Nobody Gets Credit for Fixing Problems That Never Happen," which appeared in the 2001 California Management Review Journal. Now, to be fair, they were focused on manufacturing, but the concepts of working harder and working smarter very easily translate across to building software and other types of what you might call knowledge work. Now, an interesting aspect of the working harder and working smarter loops is that they are self-reinforcing and can become the default ways of working within teams. The reason for this is that once people start working harder, their capability to do the work begins to be eroded, and therefore the only way to continue performing is to work harder still. While if they adopted a working smarter model and they successfully improve their capability to perform, then they'd have even more time devoted to the capability improvement process, which continues to reinforce that behavior. Just keeps going round in a virtuous cycle. Now, the working harder loop isn't all bad. In short bursts, it can be helpful for modeling those unpredictable, unplanned, urgent issues. But if those urgent issues are happening quite regularly, then there's a good chance that the team falls in the trap of always working harder. The working smarter loop isn't all good either, because the more complex your work is, and building software tends to be, the longer those capability improvement tasks are likely to take, the failure rate is likely to be higher, and the overall improvement could be harder to measure. So, how do we work smarter? Well, working smarter is all about improving our capability to do the work. And in particular, it's about smoothing the flow of work through our teams by removing bottlenecks. But in order to be able to do this, our teams need to adopt a learning mindset that allows them to learn while doing the work. And one of the best ways to do that is through experimentation. But taking an experimental approach to our work doesn't come as naturally to most people as most would like to think. Simply asking people to experiment more might work, but I think we can be a little bit more deliberate here, helping people to experiment more effectively through collaboration. Now, this is where leadership at the team level is vital, and it's what I mean by support from leadership teams, as they have the greatest influence on setting the direction and helping the teams adopt a more experimental approach to their work. But team members have an important role to play too. To start, there are 5 key areas that they need to focus on. The first is positively framing the work. Second, showing fallibility. Third, establishing psychological safety. Fourth, helping team members work across discipline boundaries. And fifth, helping team members learn from failure that will inevitably occur from the experiments. And what these 5 behaviors do is encourage people to share and learn from each other, which is exactly what we need when we're experimenting and heading towards working smarter, not just harder. Now, I've only scratched the surface with these behaviors and how they help teams experiment. If you're interested in learning more, then I highly recommend checking out this book, which has concrete examples on all those 5 behaviors and exactly how you can go about implementing them in your teams. So another key aspect we need to consider is, what does speed and quality mean? What you tend to find is our definitions of speed and quality are quite open to interpretation. What's fast for me might be slow for you, and what's a high quality bar for you might be a low one for me. And this means that speed and quality can vary quite a bit and can be very difficult to understand and knowing if you're working hard or smart. Now, luckily for us, a lot of research has already been done into this, in particular by DORA, or the DevOps Research and Assessment Program, which has spent about 6 to 8 years researching what practices and capabilities drive high performance in software teams. Now, if you haven't heard or read any of these papers, I highly recommend you do so, as I'm only going to focus on a small part of it, but from my perspective, quite significant, which are the 4 key measures they identified that are a good proxy measure for your speed and quality. So, the terminology used is a little different. Instead of speed, they use throughput, which they recommend using delivery or change lead time and deployment frequency. And instead of quality, they focus on stability of the system deployed, which they recommend recording your mean time to restore service for failure and change failure rate. But these are not the most self-explanatory, so I like to think of these as questions instead. So for lead time, how long does it take you to go from code commit to running in production? For deployment frequency, how often do you deploy small batches of code to production? Why both these measures are not just one? Well, lead time tells you how quickly you can make a change and get it through your build process, whereas deployment frequency tells you how often you're deploying. For mean time to restore service, how long does it take you to restore your degraded end user service? Now, degraded end user service is anything that stops your users from carrying out a task and you have to remedy that problem. Now, the great thing about this measure is that it's embracing failure and says, we know issues will occur. So how quickly can you resolve those issues and get your system up and running for your users? And finally, change failure rate. What percentage of deployments result in degraded end user service? While we want to embrace failure, we want to be doing our best to make sure we're not intentionally causing more problems by deploying too frequently. So this lets you know if you're regularly pushing out a dud release to your users. So how do these 4 key metrics relate to working harder and working smarter? Well, working harder will be focusing on throughput and stability as separate things to achieve and seeing them as alternatives. Alternatively, working smarter will be looking at these measures in a much more holistic way and trying to get a better understanding of how you're performing as a team and trying to get to the point where you're going fast and producing a quality release, but in a sustainable way. Now, as a team, by agreeing to use these measures and using the same terminology, it allows you to remove some of the ambiguity I mentioned earlier about what does fast mean and what does quality mean. Now, these measures are by no means perfect, but what they do is they allow us to reduce some of the uncertainty in the way we work, which means we can have much more informed decisions based on data rather than just intuition or expert opinion alone. And what this means for software teams is that the conversations are much more focused towards what working smarter means and seeing what can be done to improve their capability to do the work. Now, we can still use the working harder loop, but for when it's really needed. And as always, defaulting back to working smarter and looking to learn why you need to work harder in the first place. You also now have a set of measures that also tell you how successful you're being at improving your ways of working and the system you're building and maintaining. So the natural question that follows from this is, how do you get started? So assume you have nothing at the minute. A good place to start is with throughput, as this measurement covers your whole delivery process. So getting to a good understanding of what this is can help everyone see how you contribute towards delivering value in your team. And one of the simplest measures to understand is deployment frequency. Now, you really want to make sure you do this as a team, not just delivery or the engineering team going off and figuring all this out and presenting it back to the team. If you do this as a team, it builds buy-in from the start and helps everyone develop their understanding together. And to start, keep it simple. Start with just finding out how often do you deploy to production. And you can usually do this simply by looking at your last couple of release notes for the last couple of months, or just start recording from now. See, when you're starting out, knowing down to the last minute how often you deploy isn't going to be that helpful. And all those conversations around what's small and what's a batch is going to be a distraction. You can start looking at that level of accuracy once you start to improve your deployment frequency. So once you've got some data, present it back to the team. Now, I've left code in because what we tend to find is that teams get hung up on about pushing features to production. So they incorrectly believe that deployment frequency is all about pushing more features. But it's not. It's about pushing code to production. Now, some of that code could be featured, and some of that code could be inactive. What we want is getting the team used to pushing to production regularly, repeatedly, and consistently. So now that you've got some data and a team understanding of what the data shows, you can start to look at how you can work smarter. And a great way to do this is using the 5 focusing steps from the theory of constraints. So let's take each of these steps in turn to understand how they can help you work smarter and improve your throughput of code deployment. Step 1, identify the system constraint. So you've partly done this already by looking at deployment frequency, but what is it about your deployment process that is causing you the biggest slowdown? Or what is constraining your ability to deploy more frequently? And remember, it's deploying code, not features. The best thing to do here is to model your deployment process as a team. Now, a simple technique is asking everyone on the team to create a mind map of how they think their deployment process works, and then each person does a show and tell, while you simultaneously create a new mind map made up of all those smaller ones. And what this will do is give you a model of how the team thinks their deployment process works and helps you identify what parts of your process is constraining your deployment frequency. Now, if you're interested in learning more, then I highly recommend checking out this TED Talk by Tom Wujek. He describes a great process on how teams can model their ways of working using Toast. I know that sounds a bit weird, but trust me, it works. We've used it quite a few times at the BBC, and I can show you how we can do that as well. And it's only 10 minutes. So from there, we move on to step 2 and 3, which is all about exploiting the system constraint and subordinating everything to it. This is all about looking at the low-hanging fruit in your process. Exploiting is all about making quick improvements to the existing process and making the most of what you have right now. And subordination is about removing all the processes that feed into that constraint and making sure more work isn't going in than the constraint can handle. Step 4, elevate the system constraint. If the constraint remains even after exploiting it to its full potential and optimizing all the parts that feed into it, then you can start looking at ways of radically improving that constraint through experimentation. And a great technique for this is using something known as the crazy eights. I won't go into the full details of what this is, but this is a great way for teams to come up with lots of different ideas quickly. Then, once you've got your ideas, you can use an impact effort matrix to work out which of those ideas will give you the highest impact, but also the lowest possible effort. Then it's all about running those improvement ideas as experiments and using the principles of experimenting collaboratively from earlier and keep working on this until the constraint has been mitigated. And I'll provide links for crazy eights and impact effort matrix later on as well. Step 5, do not allow inertia to cause a system constraint. Now this step is all about making sure you don't just stop and go back to business as usual. Now that you've proven out an approach and made releasing faster, you can start looking at improving your accuracy in your measurements and start the process over and see where the constraint has now shifted to. Because the constraint will move. It's a bit like a balloon that if you squeeze in the middle, then one of two things will happen. Either you squeeze too hard and it bursts, or it pushes the air to either sides of the balloon. In this case, it pushes the constraint to other parts of your process. So you now have to work on where the constraint has now shifted to. So now, are we working smarter? Well, what have we done? We've got a team understanding of what throughput means and specifically focused on deployment frequency. We've also got the data and a technique, the theory of constraints, on improving our capability through experimentation and learning. So we've got most of the parts on how we can work smarter. But we're still looking at throughput and stability as two separate things. Which means that while we successfully found a new way to improve our speed, throughput, there's a very good chance that we sacrifice quality or stability of our system. Potentially, what we're doing now is something that my colleague is really fond of saying. We're shipping, you know what, a little bit quicker. So how do we take a more holistic approach to throughput, speed, and stability, quality? So this is where the idea of metrics intention comes in. Once you've got a handle on what deployment frequency is and how to improve it, it's a great time to start looking at your stability of your product and specifically change failure rate. And again, this can be done manually at first. Look at the number of releases you've made, what percentage of those resulted in end user facing issues. And remember, those are issues experienced by your users that you had to fix, not issues you caught before releasing to users. And what this can do is act like a countermeasure and helps you understand if your improvement efforts are working harder or are actually working smarter. So to summarize, what we covered today. Working harder is focusing on doing the work, and in some cases, by any means necessary, as fast as you can. Working smarter is doing the work, but focus on improving your capability to do that work through experimentation in a supported environment, slowly and steadily. But in order to work smarter, you need to shift from a purely execution mindset and towards a learning mindset. One that is focused on learning through experimentation, that embraces the inevitable failures that occur and collaborating with your teammates. And to help drive that mindset, we need to shift our mental models that simply view speed and quality at opposite ends of the spectrum and start to view them as two sides of the same coin, which is delivering value to our users. But speed and quality are highly subjective. So in order to build that common understanding, you can use the DORA key metrics of throughput and stability to drive that group understanding within your teams. Then, to get started and working smarter and learning while doing through experimentation, you can use the theory of constraints to work on the highest value areas for your team, and then use metrics intention to take more holistic approach to working smarter and start to view it at speed and quality. So to finish, and back to my original question, can you have both speed and quality? Yes, I believe you can. And by taking the time to understand why we think we can't, we can start to see ways to how we can. And maybe instead of calling it working smarter, let's just call it what it is, continuous improvement. And with that, I have one last question for you and your teams. How are you working towards continuous improvement and not just working harder? Thank you. I think we've got a few minutes for questions, maybe, I don't know. Yeah. Further reading, everyone wants it. There's a link there on the side with all these links and even more. And if you're interested in learning anything more about this stuff or anything else I've spoken about, check out my newsletter. Question at the back.
So you're talking about basically like tracking the delivery / change lead time. But like as you squeeze that balloon, right, and things start moving, what happens when it starts going to more the discovery / business side of it? Have you had to like deal with that?
It will. It inevitably will. And this is kind of where you start this is when I say you want to do it as a team. We often just think it's a software engineering team, but there's so much more than that. There's the rest of the business, there's the product people, there's the people that are making those decisions, and you slowly want to start pulling them in and getting those parts of the process closer and closer together. Now, if it turns out your business can't do that for whatever reason, then it might be that you are constrained at those points and you can't do much more in those areas.
Yeah, I mean, I've found in the past you kind of have to do that bit of like, you say you can only move as fast as your slowest moving part, and then they don't like that.
Yes, yeah, they really don't like that. And this is what kind of often where we kind of go, okay, how can we work closer with you? How can we work better together? With can we break down our work into smaller pieces and trying to bring them along that journey? One of the things we found is if you just do this at the side with the engineering team by themselves kind of figuring all this out, you then have to then go through that whole process again with the rest of the organization to help them understand what we're doing and how we're doing it. So the earlier you get more of those people involved, the better. But you're right, it is tough sometimes. Question there?
How do you like to start the timer for mean time to restore? Is it from the user report of the bug, or is it from the commit that actually caused that issue? And I suppose as a follow-on, would you also measure it for something that was only noticed internally by, say, a tester? Would you include that as well, or just user-reported things?
So, it varies from organization to organization, team to team. What I would say is, as an organization, define those up front for yourselves and your team. So one of the things that we like to do is we look at it from the point where it's gone into the live environment. When did that commit go out into the public domain? And at what point was it then discovered by either end users or hopefully via our own observation and kind of metrics and kind of other things we've built into our system to kind of detect these issues early. So we don't differentiate between end users detecting it in the live environment or us. As long as someone detects it, that's when the clock kind of starts, and when we trace it back to kind of go, well, okay, when did this issue appear in the live environment? So we run it from that time onwards. But what I would suggest is make sure you've got an organizational understanding of what those measures are and when you're going to start this clock so you can compare across teams if you need to do that.
I suppose the thing that's important is watching the trends rather than how you're actually measuring it exactly.
Exactly, right. The individual times aren't that important. It's the kind of, as you say, the trends. That's where we're really interested in, and where those numbers are kind of, are they going up? Are they going down? Are they getting better? Which is it? They're the ones that you want to be looking at.
Thanks.
Thank you. Any other questions? Okay, I don't know. I'm around for the rest of the day, so if you've got any other questions, by all means, come find me. Otherwise, thank you very much.